Welcome to Ask and Learn.
In this problem, we're going to talk about Newton's second law. So what we need to remember is that the sum of all forces that act on a body, that is the net force, is equal to the mass of that object times its acceleration. And in our problem, we have to find out which force is responsible for making a climber be able to climb up a rope. So notice that, let's say that this is the rope. The climber is holding it in his hands, and the climber is moving upwards. Notice that the forces that act on the climber are the gravitational force pointing downwards, and also on the hand of the climber there is a friction force. We'll call it FF for friction force, that the rope exerts on the hands of the climber. So for the climber to be able to move up, he must, uh, the force, the friction force that the rope exerts on his hand must be greater than the gravitational force that the earth exerts over his body. And here I'm saying friction force because the hand of the climber is going to exert a certain force on the rope, and the rope is going to respond with friction because there must be some friction so that the climber doesn't slip down. Um, and the rope is going to respond with some friction, and as long as this friction force is greater than mg, then the climber will move up. Now, this will correspond to the tension T on the rope. Okay. But in the end, the answer to our question is the friction force that the rope exerts on the climber. And this is the answer to our exercise.